Hello everyone, let's talk about the problem of reversing the linked list today. This is one of the problems in blind 75 list. This is a kind of easy problem, but a very conceptual problem, and the concepts from this problem can be used in many other problems. Okay, so for a linked list, we know that it doesn't have any random access. So we just cannot jump to any node, right? So what we have to do is we have to start from the beginning and then go all the way, because this is a singly linked list for this problem, right? So we can just go in one direction. So if we want to go to the last node, we have to start from the first node and go all the way. Okay, so this is an important thing. And the other thing about linked list is the linked list stops with a null node. That is another thing to consider. Okay, so the problem description says that we are given a head of a singly linked list. This is the head. We have to reverse the list and return the reversed list. So that means we have to reverse this. This linked list is 1, 2, 3, 4, 5. We have to return 5, 4, 3, 2, 1, where the new head is going to be node 5. Okay. For the second example, you see there are like two nodes, 1 and 2. We have to return this linked list with the new head being 2 and 1 being next to 2. Or if the linked list is empty or null, then we have to return null. Okay. So a few things in a linked list, we cannot randomly jump to any node. And the second thing is we have to be very careful about the null at the end. Okay. So let's think about this. Well, I would give you some time so that you can think yourself and then come back. I will try to discuss it in two ways. To me, the first thing that is more intuitive is like kind of a solution where I will uh, go all the way and then to the end and then start like changing the nodes, right? But the problem here is uh, if I go all the way down, if I come to this node, right? Obviously, I have to stop somewhere, right? If I see that I have reached a null, then I will stop. But if I want to go back, then when I'm here, actually I have no link backwards. So how do I remember my previous node? Well, if I do it recursively, probably I can do that, right? So say the recursive function that is a reverse, right? So this is the recursive function, reverse. Let's write it a little bit clearly. So this is the reverse function. Initially, you see that reverse is called with node 1, right? And that one will call reverse like node 2. That will call reverse node 3. That will call reverse node 4. And this will call reverse 5. Now at this point, you see that the next node is going to be null, right? So that means any recursive function has to stop somewhere. Our stopping point is going to be, say, this is the reverse function, right? So our stopping point is going to be if, say, the current node. So the current node is equals to null, then we will stop. Okay, so let's say it will be current or current next to current, right? The reason I'm saying next to current is if this is the case, then we'll stop, right? We'll return. Okay, so that's one part. And then otherwise what we are going to do is we will, let's say list node P is going to be, we'll call reverse again with the current next, right? Okay. Okay, then what are we going to do? We are here, right? So that means here we are going to, we have reached a point where we are going to hit this, right? Either myself is none. This is, I'm using this because the whole list might be like this. The whole list might be empty or null, right? Okay. Or it may not be empty. I'm here and then my next node is null. So I have to start returning. So I'm going to hit this now, right? At this point. So what I'm going to do is I'm going to return 5, right? So I'm going to return 5. Okay. So next thing is I am now here. So my current node is now 4, right? Okay, so my current node is 4. So what 4 does is it called reverse with 5. So it was calling reverse with 5, and 5 was actually put like return to P. So P now has 5 in it, right? Okay, so this is P. It has 5 in it. And as you see, now I am here, right? I'm here. So what I have to do is, you see, this is, I have to actually delete this and put it here, right? That's the first thing I need to do. So my current node is here, right? So current dot next dot next. So this is current dot next to next. I have set it to current. So you see it here. So this was current dot next, and this was current dot next, right? So I'm setting it to current. Next thing what I have to do is I have to remove this link, right? I have to remove this link and set this one to null, right? I have to set this to null. So current dot next goes to null. And then what do I return? I return the same thing, this P, right? Okay. So I return P. So I return P again. P has 5 in it. So I return P. Now, next time you see my current node is here, 3, right? So what is my current dot next dot next? This one, right? This is my current dot next dot next. So what do? I just remove this and set this here. Do you see that? And then I remove the next row. So I remove the next and set it to null. Okay, next you see my current node is here, right? So I start here. This is not true. Then list node P. So this one is was actually calling uh, with 3, right? Okay, so this one was calling with 3, and then this is current dot next dot next. This one is removed and put here, and current dot next is actually set to null, right? So this one becomes null. Similarly, next I jump here, right? Finally, I jump here. So, okay, so I had finally moved P here, return P, and next I jump here. Now you see my current node is here. This is my current node. Current dot next is this one. So I actually set it to here. Sorry, this one. And then current dot next is this one, right? So I remove it and set it to, sorry, I set it to null. And finally I return P. So you see P has this one, right? This is P. And now if we consider P as head, you see 5, 4, 3, 2, 1, right? Okay, so what is the time complexity? As you see that we have actually gone through the whole list just once and come back up. So this reverse function is called just like 5 times every once with every node. So it's order of, if the length of the list is n, then it's order of n. That is the time complexity. But the space complexity, you see here that this, so this is the call stack, right? So the call stack length is also n. So that means at a particular point, the stack may have like n levels. So space complexity is going to be also order of n. Okay. Okay. So that seems more intuitive to me, but there is a space complexity of order of n. So let's code this. If head, that means we are given a null or a linked list with just one element. Then we return head. Right? We call this reverse list again with the next node. Right? Okay, and then what we do is head dot next dot next. We set it to head, and then head dot next. We set it to null, just the way I explained, and then we finally return p. Okay, so to make it more look like how I explained, let's make this a helper function. Okay, let's call this a helper function. So list helper, where I will just replace the heads with current. Let's keep the original function, just I will call it, we call the helper function with the head. So the original function was with head, right? We'll call this one. Okay, so there might be some typos and other stuff. Let's see if it runs. Okay, sorry. This is a recursive call, so I have to call this. So I have to fix this. So for the iterative form, let's think about this idea first. We have 3 nodes, right? They're like this. And then there are other nodes. So this is the, if we think this is the current node, this is the next node. So say um, next node, we say next node, and this is the previous node. Okay, so what we have to do, this is the current node. What we have to do is we have to remove this link and put it here, right? Okay, but if we do that, you see that I am losing the trace for the next node, right? So I have to, what I mean is current dot next is previous, that is fine. That is fine. But before that, I have to save it somewhere, right? So let's say we call it next node. Next node is equals to current dot next. I will save it somewhere because I don't want to lose trace of it. Because once I break this link, immediately I may lose trace of it. So current dot next is set to previous, that is fine. And then, yep. And next, what I have to do is next time I will change this to previous and this to current, right? So I'll do the same thing. So that means current becomes now, the next node becomes the new current. And the, first I have to do this. I have to make the current to previous, and then I have to change the next node to the current. Okay. So I will keep on doing this while, so at some point I will reach null, right? So the current will go to null at some point, while current equals to null, right? Okay, now let's think about a whole linked list. And you see, let's call this 1, 2, 3, 4, 5, right? Okay, so obviously at the beginning, we'll check if the node or the head, or if the current is equals to null, or yeah, current dot next equals to null. In that case, or let's instead of current, we say head. If the head is null or the next to head is null, that means either we have an empty linked list, or we have just a linked list with just one node, right? In that case, even reversing them we don't need to do anything. What we do is we return the head. So this is the initial checking we do. We'll do it at the beginning, and after that, we'll do this. Okay, so for the first case, we have to make a dummy previous, right? So we call it a dummy for the first node. When this is the current, where do I find the previous, right? So let's make this one. So let's have a null node as previous for now. Okay, so what you are going to do is we're going to just delete this. So this is first I'm going to set this as next node, right? And then I'm going to delete this. This is current.next, right? This is current.next. So I remove this link, set it to this, to the previous. Yes, so I'm doing this. And then I am making the current to the new previous. This is this line. Next line is I am making the next node as the new current. There goes the first one, right? Okay, so current is still not empty. So what I'm going to do is I am going to save the next node. So this is the next node, which is current.next. And then I set the current.next link to the previous, and then change this to previous, and this one to current. So I'll keep on doing this until my current reaches here, and then I'm done. So this is the iterative solution. Okay, so let's try to do the iterative solution. We'll have a previous node. Initially, we'll set it to null, and this node current. The current node is set to head initially. Okay, and while current is not equals to null, then what I do is I first save the temp, the next node, so current.next, so that I don't lose it. And then current.next is set to previous, right? So, and then previous becomes current, becomes the next previous, and the next temp, this one becomes the next current. Okay, and finally we return the previous. The reason we are returning, do you remember? Like, can you understand why we are returning the previous? So we're returning the previous because our current at the final stage, our current is pointing to null, and the previous is actually pointing here, right? So we have to return this. This is the new head. That's why we're returning the previous. Okay, so that's it. Thank you very much for watching.